Thank you. Probably the biggest challenge of the night. So thanks for welcoming me, and I'm very happy to be here. I'm going to talk about SonarQube and SonarLint, which is a sister project of SonarQube, and regarding the .NET ecosystem, what we offer for the .NET developers. I'm Tamas, as you heard. You can find me on Twitter. I'm a software engineer, and I'm in the language team of SonarSource. So why do I say that? So SonarSource is basically a development company, 45-ish people. 25, 30 of them are developers. The rest do the job to sell the stuff. So, and we are composed of smaller teams. I'm part of the language team, which means that I'm developing language analyzers. I'm going to actually start with that tonight, but as well, we've got the platform team who developed the whole platform for the SonarQube platform, the UI, and we've got a couple of other teams. Scanner team, I will show some stuff from them. Yeah, and I'm also a Microsoft MVP, which I mainly got for my open source .NET contributions. So whatever you see tonight is all open source, free. You can grab it, you can use it, and I'm more than happy if you use it. And if you have feedback, bad feedback, good feedback, just send us, and we'll fix it if it is a bad feedback. So let's get started. I will mainly talk about two things, SonarLint and SonarQube. Let's start with SonarLint. SonarLint, who knows what SonarLint is? Who uses SonarLint? Okay, who uses Visual Studio 2015? Okay, who doesn't use Visual Studio 2015? Okay, that's perfectly fine, it happens. So SonarLint is basically an IDE extension for detecting bugs on the fly as you type and provide quick feedback to users. And it's not just this Visual Studio extension, it is also there for IntelliJ and for Eclipse. We tried to maintain the same functionality between these three products, but I'm going to only focus tonight on Visual Studio because that's why we are here. So as I said, on-the-fly feedback to developers, and the main aim is actually to find bugs and quality issues. So about SonarLint for Visual Studio, it's analyzing, it basically does static code analysis. It analyzes C# code and VB.NET code. I emphasize this because the other products analyze many languages like PHP, Java, JavaScript, maybe COBOL even. But SonarLint for Visual Studio right now only supports C# and VB.NET. And why is this restriction? Because SonarLint is based on Rosslyn, the .NET compiler framework, which only supports these two languages. So who haven't heard of Rosslyn? Okay. Who has used Rosslyn? Like everyone who raised the hand for Visual Studio 2015 is actually using Rosslyn because that's the compiler inside Visual Studio 2015. But who has written analyzers or who have used it for whatever reason? Okay, not a lot. So if we will have time and you are interested, in the end I'll show a couple of things about it. So Rosslyn is the compiler framework. It's an open source compiler, and it's also an open platform, so you can inject your code, I mean not your code, your functionality you can inject into the compiler pipeline, which means that whenever the compiler does like a compilation process, like a syntax analysis, you can inject your own syntax analyzers into the tree, into the pipeline, and then your stuff gets executed natively inside Visual Studio, inside the CSC compiler, so basically as part of the build, which is great because it's a native integration, so in Visual Studio you don't have to let's say, start an analysis, like currently with FXCop. If you want to do the static code analysis, you click on the analyze my stuff, and it's an additional step. You don't have to do that if you are based on Rosslyn. What's also great is that we don't have to write the parser and the semantic model for it, which means that we won't have any parsing issues, and we will have a complete and good semantic model, so we will be able to provide good information to the end user. And also, native integration means that the standard shortcuts work, standard keyboard shortcuts work. We get code fading. If, for example, we have some redundancy in the code, we can fade the code itself. And also we get code fixes. So, I mean, we can provide code fixes, which is like if there's an easily recognizable and easily fixable issue, then that can be probably automatically fixed. You hit Control dot, a pop-up comes up and shows that, okay, we can fix this. And then it's very easy to provide code fixes as well, not just analyzers. This code fix stuff is actually unique for SonarLint for Visual Studio. The other SonarLint products don't have it because they don't have the necessary tooling for it. They will probably have it in the future. And we will have JavaScript analysis in the future. So it is all coming together at one point. So I think that's my last slide on SonarLint because I just wanted to demo stuff. So I'm gonna go to Visual Studio and probably go full screen and increase the font size. So how do you get SonarLint? First problem which you need to solve. You go to Tools, Extensions and Updates. You go to Online, and then you search for SonarLint. And then it shows up, you click on it, you install it, and boom, you have it. Whenever we release a new version of it, we try to release like every 3-4 weeks with new features, bug fixes, whatever came up. You get it automatically, so you don't have to care about it. So I already have it installed. So let's see what we have. We categorize issues, like our whole company is based on static code analysis, and we've got a huge rule database, like problems which can come up in Java, which can come up in C#, which can come up in JavaScript, in COBOL, in PL SQL, many languages. Some of these issues relate to many languages. It's all unified in one place. So we have a rule database, basically, an issue database, and we categorize our issues into findings, so small issues which are not really big issues, but you can simplify your code somehow, for example. Then the second level is maintainability issues, so like very big redundancies in code. Then there are bugs, like a null pointer exception, no reference exception, and there are security vulnerabilities, like code which is prone to SQL injection, let's say. Security vulnerabilities are the toughest ones, so we don't have a lot of security issues recognized right now. But I can say, like, for example, there's a rule saying that you shouldn't use MD5 hashes because that's a security problem. It can be hacked. And then whenever you new up as an MD5 hashing algorithm class, we underline that. So let's see a couple of issues. Like I prepared like a very a demo web application with this is because it has JavaScript code in it, and in the very end I want to show how we can analyze JavaScript as well. So let's say if we want to see like a finding, then I'm going to create a new int array and initialize it with a couple of items. And as you can see, the int got faded out because you can actually get rid of it. The code will be exactly the same. It has no performance benefit, it has nothing. It just simplifies your code, so it's a finding. And this one actually has a code fix, so we wrote a code fix for it. This is the native integrated way of Visual Studio showing code fixes. So you control dot on it, and then the light bulb shows the actual fix which will be produced. You can see the before and after state, and also you can apply this for documents, project, whole solution, whatever you like. So and then you can accept it, and it simplifies your code. So that's like not really a big issue, but it's pretty nice. This shows the native integration with SonarLint. Let's see a couple of other things. So implementation-wise, we can categorize the issues differently, like how tough it is to actually find this issue. So there are issues which can be found by just simply looking at the syntax tree, which is produced by Rosslyn itself. By the way, Visual Studio has an extension for checking out the syntax tree, which is pretty useful when you are developing rules. So if I click on it, it highlights what's the syntax node. So what kind of issue comes into mind for this case? Let's say I'm doing like a calculation int x equals b plus, oh, that won't work probably, b plus b, let's say. That's a bool. Let's make it int. Yeah, plus is not there yet. Okay, so then, sorry, let's make it bool x equal b x or b. And I move it back to bool. So we detect it as identical sub-expressions on both sides of a binary operator. And is it an issue? It's not really an issue. Maybe it is a valid code, like as you see on the plus, we didn't say anything, because it happens that you use the same operand on both sides of a plus. But in case of XOR, you perfectly know the result after this operation. So it's an issue. You shouldn't have something like that in your code. The same goes for B and B. This is something which again shouldn't show up in your code. So we detect these kind of things. And it's very simple. Basically what we do is in the syntax tree, so in this syntax tree, we subscribe to logical AND expressions and check the operands if they are syntactically the same, so the nodes are the same. It's very easy, and you would say that you never find something like this in real code, but that's not the case. So we do analyze many open source projects, or a couple of open source projects, and I'm going to zoom a bit. And one of the biggest ones which we analyze is Rosslyn, which is like, I don't know how many million lines of code. So basically here what they had, they poured together the exact same stuff, which is definitely not what they meant. And so this is a typical use case for copy-paste issues. They just copy-pasted it and they forgot to change one of the variables. But from the context you can find out that, okay, we are always checking current node and, okay, sorry, we always check token and next in a pair, and they just forgot to change it. So this one we found, we sent a pull request, it got accepted, cool, we found an issue. Also, a very similar one is when you've got the question mark colon operator and both sides of the when true and when false parts are the same. That's again redundancy. It's definitely not what was meant, or it was simplified since then. So you can simplify your code, and that's also in Rosslyn. And if you check the history of this file, you see that this method actually previously had an additional parameter, and that was different. But then they removed it and forgot to clean up their mess. So it's pretty easy to find issues even with this rule, and if we will have time, we can have a look at Rosslyn, and if we have time, I will show how to implement this rule in like 10 minutes, let's say. A next level of technical difficulty is when you need semantic information. What's semantic information? Like type information. For example, let's say I've got this piece of code here, and who knows what thread static is? Does anyone know? That's pretty amazing. Like, okay, who can tell me what thread static is?
I guess it's when variable is static only for the thread.
Yeah, that's a very good answer, or a very good guess. Actually, at the end of the presentation, just feel free to come up here and I'll give you a t-shirt for it. And the reason for that, because what you said that the static variable is static for the thread. But what happens if this static variable, if this variable is not static? Then actually thread static has no use at all. So in this case, we detect that, okay, this is a non-static field. There's thread static on it. We say that, okay, that doesn't make sense. Remove it. It doesn't add anything to your code. And this one also has a code fix. So in this case, why do we need semantic information at all? We could check, checking if a field is static is easy. You can check for the static modifier on it, so that one doesn't need type information. But thread static can be in different formats, like it can be thread static, it can be thread static attribute, it can also be with its namespace. So you don't want to handle all the cases, you actually want to get the type information belonging to that given syntax node and use that information. So we've got this rule as well. Like, I honestly never met anyone who used static before, but in this room there are at least 4 people who said that they know what it is. And how do we find these rules? Like, how do we come up with these ideas? It's very easy actually. You go on MSDN, check all the remarks, and they say that, okay, like this only applies to static fields, and also it has a note on it. So let's see what that note is. That note is actually that having thread static on a static field is good, but don't have any initializer for it, because the initializer will only run once for the first thread who accesses this field. Everyone else will get the default value for their thread. So it's kind of unexpected. So that's what we say here, that okay, remove this or make it lazily initializable. So this is one for the semantic model based rules. And with this one, with these 2 pieces of information, you can get quite far. So with the correct syntax tree and with the semantic model, you can do pretty amazing rules already. So let's see a couple of other things which we found in real world code. So that's why we have the rule for them. So if there's an if-else or if-else-if chain, then it's not great if you have the same condition in the if-else chain. If you have it twice or many more times, then only one of those blocks will execute. And if you have the same block somewhere, then you should probably merge the cases and not duplicate the code. So this is what happens here. We say that okay, this code already showed up in the C files chain on line 17, so merge it. Do we merge it in this case? No, we don't. We don't have a code fix for it because it was, I mean, it could be done, but it's like asking for trouble. Do we consider comments in this case? Maybe one of the blocks has different comments than the other one. Then we still report on them, but maybe there's a reason for actually having two separate blocks for it. So there's no code fix for it. Also, there's a simple syntax-based one. It's like a naming convention rule. So this is a convention-based rule. It might be controversial, but generally it applies to C# that all your methods should be capitalized, I mean Pascal cased. So in this case, we say that okay, this is not good, this naming is not good. There are exceptions, of course, like in tests, you kind of want to allow underscores in test method names. Also, in case of, we've got a similar rule for class names or type names. Their interfaces usually start with a capital I, because this rule also checks if many characters consecutively are actually capitalized, because then it shouldn't, and it proposes a good name for this method. We have the same rule in VB.NET, but VB.NET, we had a VB.NET plugin. Who is developing in VB.NET, by the way? Okay, at least one. That's great. You've got this rule in VB.NET as well. But in VB.NET, it's actually a parameterized rule, so you can define a regex, and all method names should conform to that regex. The problem with regexes is that it's pretty difficult to actually propose a meaningful resolution for it. And the regex for this rule is like this long, or maybe this long. I'm not even sure, because it handles the underscores as well. So you don't really want to have these kind of parameterized rules. Maybe it is going to change in the future. So as you see, I changed the method name. So this method doesn't reference this method anymore. This is a private method which is not referenced anywhere, so it's faded out. It's pretty standard stuff, but it's very useful. So what else we have? I think that's it. That was it for the syntax and semantic based stuff. By the way, as you can see, we say that code shouldn't be commented out. Commented code is like useless, like remove it. So let's see what's the matter with this case. I don't have the event for it, so let's have an event for it. So I'm gonna close this. Can anyone tell me what the problem is with the unsubscribe from this event? And it's the same lines except plus or minus, right?
You are not removing the same instance of the action.
Exactly. That's the problem. Again, free T-shirt in the end. And I only have like 5 large size T-shirts. Then it's gonna be small, medium, extra large. So you have to be quick. So yeah, the problem here is that you subscribe to an event with one instance of a lambda here, and this is another instance which you try to unsubscribe from. So so it won't do anything basically. So the solution for this one is not easy. So there's no code fix for it. But basically, what you want to do is get this one into a local variable, and then unsubscribe with that local variable. Also, by the way, we've got the simplification for this one as well. If I new up an event handler here, so that's also another legal way of writing the exact same stuff, but it's redundant, it's too long. This is actually pretty tough to make these suggestions. I wasn't ever until I implemented them, and it's like unbelievably tough. So what we do here, it's pretty amazing, I think, what you can do with Rosslyn. We go through we know a couple of syntax options which can be simplified. So we go through them, try to simplify them, rerun the compiler, check if it reports an error or not. If it didn't, then the simplification works, and you can really propose this simplification. So you can spin up a different instance of the compiler, and it's pretty fast, as you can see. Like there's no lag or whatever. And of course you can simplify. So if you were to ask us like 6 months ago what kind of rules we have, we would say that okay, we've got syntax-based and semantic model-based, so type information-based rules. If you ask us now, we say that okay, everything, the magic happens with symbolic execution. Symbolic execution is like just a big word for doing data flow analysis, but it sounds a lot more cooler than data flow analysis. So what do you need for data flow analysis? You need a control flow graph, and Rosslyn provides control flow analysis, but it's pretty basic, and also it provides data flow analysis, so it's pretty basic. But it's pretty basic, and the reason for that is because they didn't need any more complex stuff in the compiler itself. But we do, and these simple interfaces don't provide like a graph which you can then walk. It is based basically on a walker pattern. So when they enter something, they know that they are going somewhere, and then when they exit the given block, they know that they exit one level up. So what we did, we created a control flow graph of the whole project, of the whole method basically. It's method based, so the method body produces one single control flow graph, and this is where it gets a lot more tougher. So what I showed you, you could easily do in, I don't know, let's say in a week. When you have to create a control flow graph for C#, that gets a little bit tougher because you need to handle all statement kinds and all expression kinds. So, and there are like weird expression kinds. Like, did you know about, let's say, underscore arg list? So that's basically a keyword, the arg list, and it's only there for interrupt, for legacy code. So who used underscore arg list before? Yeah, that's what I guess. But when you create a control flow graph, if you don't handle it, then your control flow graph won't be correct. And there are some other very rarely used constructs, I would say, in C#, which I just learned during, I don't know, the last 6 months. So what can we do with data flow analysis? Basically, we can do things like this. If A equal B, and let's say that, let's start with a simple one. A not equal B, then we can say that, oh, this condition is always false, which seems obvious in this case, but it's definitely not when you handle it in general. So what we do is, for each local variable, we track the assignments to that local variable, and we basically create a symbolic value which is assigned to it. In this case, these are parameters. They will have symbolic value 1 and symbolic value 2. And when we say that, okay, A equal B, we create another symbolic value because this is an expression. Expressions have value. It's a symbolic value. What kind of symbolic value? It's an equality symbolic value, which has two operands, symbolic value 1 and symbolic value 2. When you enter the if block, you say that this symbolic value is true. And then you store this information. You do the same stuff here. You've got a not equal symbolic value with A and B operands. And when you visit this if statement, you try to put a true constraint on it as well. But then you realize that, oh, this can't be true because we already set a different constraint which contradicts this one. So we basically do this. And what other stuff can we do? So it's like condition evaluates to true or false. That's one rule which is based on symbolic execution. Another one, let's say, is O equals to null. And I try to call O.toString. This is something which shouldn't be done because it will fail. It will throw a no reference exception, and that's what we that's what we say here. So we say multiple things here. We say that toString has no side effects because we know that it doesn't have a side effect. So like, why do you call it and not assign it to anything? You are not using the result. So if I use the result, then I will have a bit clearer error underlining. So we say that, okay, in this case, O is no. We know that it's no. And we have this symbolic execution engine in place for Java. We have it for C#. We've got this for C++. We also have it for JavaScript, which is, I mean, you can see that we try to share the same logic, same ideas behind this whole stuff. Obviously, we don't want to implement it many times, but different languages have different constructs. That's kind of okay. Like Java and C# are very similar. But with JavaScript and with C, like in case of an if, you can put any variable there. You just check if it is 0 or not 0. So that's like that adds an additional complexity on top of the symbolic execution engine in C++. In JavaScript, I mean, you can write basically anything into an if condition, and it's kind of truthy or falsy, and there's no type there. So, so that's an untyped situation. That's even tougher. But C# has its own restrictions or own special cases. For example, we can have a nullable int, and I can assign null to it. Well, let's start with int I equal 5, and then I do I equal null. And we know that this is never going to be true. Even the compiler says that it's never going to be true. And the reason for that is because I is a value type, and value types by default can't be null. So it's pretty easy to say that this is a problem. But like nullable int, if you check nullable int, nullable int is actually a struct as well. How come a struct can be null, and in other places it can't? So it turns out that in C#, nullable is something which is handled in its own way. Like you can assign null to it, and yes, it can be null. So what can we do with it? We can we call toString on it, like, and of course. So if we do this, okay, in this case nothing showed up, so I'm going to create a ticket for it in Archia. But what I wanted to show, and this will show up, so we can query the HasValue. This is a special property on Knowable. And we can say that, oh, here this is always going to be false, because we know that we assign null to it. So this cannot be true. But let's say we don't know anything about it. So I'm going to pass II as a parameter. So then, of course, we are not reporting on it. And I can do II HasValue and then II.value equal 5. That's gonna still work. Let's say I say that, okay, II has no value. Then you definitely know that II is null. So you shouldn't call a value on it, because what's gonna happen if you call value on it?
Exception.
Exception. What kind of exception? Sorry?
Don't remember.
Okay, never mind, you wouldn't get another t-shirt. So it turns out it's not a new reference exception, it's an invalid operation exception. But I mean, we don't really care, it's going to be an exception in this case. So nullability is something which is special in C#. What else we have? We have, I think we have a rule on cast as well. Yes, we have a rule on cast. So let's say II has value. This II is nullable int. I can cast it to int perfectly fine. If I say this, then this cast internally will access the value property, which we know that it will throw an exception. So we report on it. What else can we find? Basically, there are I think 3 or 4 rules which are based on symbolic execution, and it's already pretty good. There are some extension coming up in the future, I guess. But let's see a couple of issues which we found with symbolic execution. And again, I'm going to show like Rosslyn based stuff, Rosslyn issues. So this is like, it's unbelievably tough to see it like this. So let's see, unified. So this is in Rosslyn in production code. This pull request was not yet accepted, so this bug will ship with VS 15, I don't know when, maybe in November. So what do we have here? We've got an expression, and without the correction, we've got an exception, an expression, or an other expression. Which seems kind of okay until you try to think about the precedence of and or. And is stronger, so basically what we have here is an expression or another expression. But wait, in this expression you check this if type is not null. So that means that in this method type could actually be null. But here you are accessing a property on it, so that will throw. And also the same applies for new type, because you are accessing a property on it. You're actually, so the problem is that they screwed up the precedence, so they were missing another parenthesis. And this is again a specialty of C#. In SonarLint, we are not reporting on this call, although new type can be null in this case. But isEnum type is an extension method. And extension methods only exist in C#, but they can accept null. So maybe that extension method handles correctly the null case, so we are not reporting on it. And this is something which is very important considering our rules, that we try to be as precise as we can, and when we can't be precise, then we play safe and either not report or not report. If we couldn't decide, then we are not reporting. So we prefer false negatives to false positives. There's another similar issue in Rosslyn. So here we were reporting that pointer is always null. And the reason for that is if you go up a bit, so pointer is different here. If pointer is not null, then we return from this method. So whenever we are here, pointer will be null, and they actually forgot to change pointer to reference. They again copy-pasted code. And what else do we have here? Oh, that's a common problem. Like something is not null and something, or something is not null or something. And in this case, again, body not equals null, or body.statement any. Like in this case, body will be null. And it's like, okay, someone committed this crime in Rosslyn, but let's say we go to GitHub and check out Scott Hanson's repositories and DOS blog and issues, maybe pull requests, sorry, close pull requests. Okay, well, this is interesting. I submitted that. So let's see the code, because that's what we like. So pingback service equals null, and pingback service of length equal null equal 0. So and we had a long discussion that this is wrong. Like if you just check out this code, you don't spot this issue. It's pretty obvious, but you don't spot it because you kind of assume that, oh, that's how we usually do. So SonarLint is pretty good in finding these issues. And that was my SonarLint demo, and it was a bit longer than I expected. So, but that's what I do. Yeah, go ahead.
Do you have a list of all the rules?
Very good question. So we've got a website called so it's either sonarlint.org, and then you choose your IDE, or it's vs.sonarlint.org, and then you get here, and then rules. And here you've got a lot of rules. These are the rules which are implemented in SonarLint for Visual Studio. And by the way, this version was just released this week. But you can go back to the previous version, and then you see the number of rules. For C#, it's 174. For VB.NET, it's 30. But if you go to the latest release, you'll see that, okay, now there are 60 rules for VB.NET, because I just spent a couple of weeks on VB.NET. So yes, you can. And then you can filter by tags, like bug, and then you can find this rule: condition should not unconditionally evaluate to true or false, and then there you have it. We try to have compliant and non-compliant description, code samples in the description. And also, it was a great question, if you go to the error list, of course, we've got native integration with Visual Studio, so all issues show up in the error list. All issues have a link, have an ID. You can click on the ID, and that will take you to the rule. But when no, you always get there, except when you are on a developer version of SonarLint, because I haven't deployed this version to the website. I prepared yesterday, I found a bug, so I fixed it in the evening. On my machine it works. So if I go to 9.10 and 1.8, so many issues here. So you can get to the rule description. And you can see that even the normal compiler issues have links, have IDs, and then you can Google it on Bing. The issue number, that's the default behavior. You somehow can't change Bing, but in code search, Bing actually works pretty well. So thank you for the question. You got a t-shirt for it. So let's get back to the slides.
Another question?
Yeah, go ahead.
I have a Resharper, but I'm going to run out of the license soon, so I want to know, should I try SonarLint or
you should definitely try SonarLint.
Yeah.
So,
But should I?
yeah.
buy
So
Resharper
I think SonarLint is good enough to not renew Resharper licenses.
Yeah.
At least that's what I did. So obviously many rules are similar to Resharper rules. So we did a study on how many rules we have, what are those covering in Resharper, and we kind of came to the conclusion that 80% of Resharper C# rules are covered by SonarLint. Resharper is a great tool. You already got used to the shortcuts, keyboard shortcuts, and it's pretty difficult to learn new habits. But you can get used to Control comma and Control semicolon, and then you search files, you search for types, methods, whatever, instead of Control T. I don't even remember. Yeah, I think it was Control T. What people don't really recognize, I think, is that previously, with Visual Studio 2013, you couldn't live without Resharper, because what you would get is this one. You wrote some code, you kind of think that there are issues in it, but they don't show up in the error list. Because there you had to build it, and then on build time, after build, the issues show up. Resharper filled this gap. Like with Resharper, you didn't have to build. It showed the issues on the fly. And who can live without that? Like, no? But now Visual Studio 2015 handles this properly. Like all issues show up as you type. So I think this was the biggest feature of Resharper, which you haven't really realized until it came to Visual Studio 2015. Also, if you do web development, then Resharper does like CSS, CSHTML analysis as well. We don't at the moment. So, you have to decide. Let's have questions afterwards. Yeah, like I'm gonna rush through all the slides, which are. I'm at slide 6 of 30, but I'm kind of prepared to not have internet, but I do have, so let's go through a couple of them. So we've seen that SonarLint is great to find issues inside the IDE, but that's not all. Like you kind of want to handle issues out of the IDE through the whole team of yours, or through some common portal where your boss can check if the code is quality-wise good or not. So how do you measure code quality? And that's like, this is one of the measures. How many what the fucks per minute when you do a code review? And if it's only a couple, then it's an okay. If it is a lot per minute, then okay, your code is not really good. And it happens if you review your own code as well. Like 2 days after you wrote it, like. What's this? So this is one measure, but it's probably not the best. So instead we are finding issues, and we introduced this quality model of having findings, code smells, bugs, and security vulnerabilities. But when you run a static code analysis on your project, like your project is probably 2 years old already, or started like 10 years ago, like you run a code analysis on it, and you've got 10,000 issues. Like, how do you start? And like, we introduced this. It's common sense as well, but no one came up with this idea before, that you shouldn't care about that. Like, okay, that's 0. You've got some technical debt. It's okay to have debt, like you have a loan from a bank, you bought a house, great, but you don't want to have a lot of loans. So you want to manage technical debt, and the problem is that you commit issues. You commit a crime and there are issues in your code, then do you check it? Like, and who checks it? Like, it's usually some other team who checks the code, like quality assurance team. It's already too late. You already committed it, so it's like in the master. So you don't really have to fix it. Like it's not your code anymore. Like so, you have to take ownership of your problems as well. Then your project might be a web project, might be a COBOL project. Like, how do you compare those two? Like, what are the requirements? Like, are they unified requirements? Probably not. Like, it's not really good. And when can you say that, okay, this code can't go into production? How do you define that? So, handling all the technical debt at once is like impossible. Like, you won't do it. There's not going to be budget to fix it. And then, okay, you fix it, and that will probably add new bugs and functional regressions and stuff like that. And most of all, for the developer, it's not fun. Like, you don't want to do that. So instead, what we propose is that the development team should own the quality. They should, whoever committed the crime should be responsible for it. Like, and it's not like your boss can come down to you and say that, okay, you committed this line, this is your fault. It's like, I want to get an email when I commit an issue, like an automatic email, and I will fix it, yeah, sure. So it's like an ownership saying that, okay, I want to fix it. You want short feedback loop, committed it, CI job runs, okay, I get the email, I screwed it up, okay, sorry, I'm gonna fix it. Or even better, I will show you. I didn't even commit to master, it's in a pull request. Let's analyze the pull request, and I want to get an email with the issues in the pull request. You want a unified kind of quality gate. The quality gate specifies that, okay, these are the requirements which you have to satisfy to go into production. Like, if the code coverage is below 80%, can't go into production. 80% on the whole code? No, 80% on the new code since you released the previous version. We don't want to handle everything at the time. We want to handle the current sprint. We have to accept that, okay, the cost is like, there's a cost of fixing bugs, but the sooner it happens, the less the cost is. And I mean, you can organize races between teams who has bigger code coverage. Like, we do this internally at SonarSource. So this can be made like, you can gamify it. Like, so it's pretty good. You can get points. And this is our metaphor. It's fixing the leak. So when you've got a water leak, what do you do? Like, do you start cleaning up from the floor? No, you fix the leak. And if the leak is gone, then you can slowly but steadily clean up the floor. And this is how we say that, okay, whatever is in this current sprint should have a very strict requirement. And by the way, as I touch old code as well, I should fix the old code as I go through the life cycle of the software. So it's basically, we've got technical debt, we accept it, but slowly but steadily we get rid of it. And on new code, we manage the technical debt quite strictly. So this was the idea in SonarQube 5, or the 5 series. Every major series has a long-term support. So that's why I'm talking about the 5 series now, because that's the latest stable version which will be supported for many years. But as we release SonarLint for Visual Studio every 3-4 weeks, the platform itself, SonarQube, is released every month, let's say. So you can opt in and get the latest updates as you go. And I'm running out of time, so I'm going to skip these slides and show it in real time instead. So basically, what I want to show is SonarQube. Let's see how we do our development, and then I show SonarQube.com as well, which is SonarQube in the cloud, so you don't have to set up a server, a SonarQube server. So we've got an internal SonarQube instance which we call Dory, And if you scroll down the page, you can see that this is on SonarQube version 6.1 build 13769, which was released, I guess, this Monday. So we doc feed our own product to ourselves. Whenever we see a bug, we want to fix it. And let's see Sonar Analyzer for C#. That's my baby. As you can see, I started the new sprint 3 days ago, so not a lot of stuff is in the orange column. Basically what we have here, we've got bugs and vulnerabilities, code smells. Those are two different categories. They should be handled differently. Code smells are not that big an issue. Bugs and security issues are big issues. And this part of the screen shows the overall technical debt, basically. This part shows what should be zero, what should be very good. This is since the previous release, so we call it the leak period. And you can see that I introduced one new code smell since Monday. We can check it out. Usually everything is clickable. So you can click on it and then we can see the issues. Now this is not really a good example. This is an issue reported by FXCup. Because we do analyze our stuff with FXCup as well, and it integrates with the platform the same way as our own analyzers integrate. So basically it says I can navigate by keyboard shortcut. It basically says that, okay, this instruction is being cast to binary expression syntax, but in this method, this instruction is already cast to the same type somewhere, so it is like you don't want to cast multiple times because it's a performance issue. The problem is this is happening in a switch in one branch, in one case section, and the other cast was in another section. So this is really a false positive. So in this case, I can come here. This issue is open now, and I can say that, okay, this is a false positive. I can give a reason if I want. If I don't want, I don't have to. And then whenever I do next an analysis on this project, this issue won't show up again. It will still show up now because we cache many things and we don't refresh the dashboard. Maybe it is going to change in the near future. So this is one way how we handle it. And I already got an email of this issue. The other great thing is that I could show the quality gate first. So what do we have as a quality gate? This is the default. Basically we say that code coverage on new code should be 85%. There should be 0 new bugs, 0 new security issues, 0 open issues. So all issues should be handled, verified by a human, by me or by whoever, that okay, this is a false positive, this is acknowledged as an issue and will be fixed at one point, and so on. And the technical debt ratio on new code should be less than 5%. Technical debt ratio is a number which is basically saying that to fix all issues, you would have to spend 5% of the time which would take to rewrite the whole stuff. So that's it. But there's another quality profile, SonarSource Champions League. You can opt in for this. Here are the projects which are opt-in for that. Basically, it requires larger coverage on new code. So that's one thing. Also, you can specify which rules should be part of your profile, your rule profile. I don't have the rights to do that because this whole system can be managed company-wise. So there is a responsible first person for that to set it up, and developers shouldn't screw up shouldn't basically lower the requirements. So each feature can be enabled, disabled for a group of people. What else do we have here? Quickly, I'm going to show it. So we do compute a lot of metrics on code which is analyzed, and we give nice green A's if you are a good boy, and we can have big red C's, like, okay, this is not really good. So basically what we have, we compute, we've got the reliability, security, and maintainability issues shown. We've got bubble chart showing that, okay, in this file, how many issues are. So you can, if something shows up here, you should definitely check that out. That's a big file with lots of issues. Like, okay, that's not a good sign. And then again, you can usually click on anything and drill down, so you can check rule details, and you get down to the file and you see the issue. What's the issue? Oh, this is a public property exposing generic list, which is a bad practice. You should expose collection instead of an implementation detail list. And who committed this line? That's kind of great. Like, you've got commit information. So it was me. Where do we get the commit information? We've got a Git plugin. We've got an SCM plugin, basically, which checks your Git folder, checks your SVM folder, checks your whatever code control, source control manager you use, and retrieves the information who committed which line. And it is shown here, so you always know who to send the email to. And the boss knows who to go to. But that's like, yeah. So there are other measures like complexity. Complexity, we miss a couple of measures here in C#. It is coming in, let's say, 2 weeks. So let's go to SonarQube Java, because that has like a lot of metrics computed. Measures, complexity. So basically we've got, we can have coverage detail as well. So what's the line coverage? What's the condition coverage? What's the coverage on new code? And of course you can drill down and you will see a list of files. And of course we are starting with the worst one. So this file is the one which has the least coverage, 40%. Okay, let's see. Like, okay, what are the uncovered lines? Oh, those are the uncovered lines. Who committed that? Okay, that was Nicola. So Nicola got an email probably that, come on. The email probably said a lot more than come on, but he knew that this was meant. So how do we use it daily? Do I have like 5 or 6 more minutes? Someone tell me if I should stop. Yeah? Okay, 5 minutes is good. So how do we get the analysis result into this web portal? That's kind of the big question. How do we do it for C#? So how do we do it in general? I'm gonna, I haven't showed the GitHub pull request commenting, but here's a screenshot on it. So basically, we've got a bot which can comment on given lines saying that, okay, this line has an issue, which is kind of useful. Like, it is very useful. So the overall architecture previously was this. I don't care about the past. So source files, there are so-called scanners. So we've got for .NET the SonarQube scanner for MsBuild. That will send the result to SonarQube. SonarQube has internal engines, background processes to process the reports, compute whatever needs to be shown, and then it goes to the DB and a search, a caching is put on top of it. So that's basically the overall architecture. So how does the scanner for MsBuild work? Basically, you get an executable, you run it, then you run a build, then you run the executable again, and everything is done. So let's see it for our little project here. I'm gonna get rid of the compile errors, so I'm gonna save it. How would I build this project? I would probably do MsBuild. I would probably specify that, okay, I want to rebuild, and I would specify the solution in demo. demo solution. Run it. Analysis is running. I mean, compile is running. Okay, that was it. We've got 2 warnings. Who cares? How do you analyze this whole stuff? You basically don't want to change how you build it. You just want to do something before it and after it. So there's an executable which you can either download or you can install it from Chocolatey. I did exactly that. So if on Chocolatey, that's a package manager for Windows, you search SonarQube, you will find a couple of products there. Someone created an installer for the physics as well. But basically you are looking for SonarQube scanner for MsBuild. It can be found as an executable as well, so if you don't use Chocolatey, that's fine as well. And then I already set up an analysis build script for it because I'm lazy to write anything by hand. So how do I increase the font size? Okay, I don't know how to increase the font size. So basically you run the executable, you say that it's a begin step, you specify that on SonarQube each project is identified by a key, what should be the key, each project has a name, what should be the name, and each project has a version, I mean like what's the current sprint you are in. You want to build, just to be consistent, I can write rebuild here, and then you want to run the end phase. So let's run this whole stuff. Where will it connect to? By default it will connect to my local instance, local SonarQube instance, which is running on port 9000. So let's run this. Okay, begin step. What does the begin step do? It connects to SonarQube, pulls down the settings. What are the rules that are enabled? What version are we at? And put that into your local machine somewhere. Then you run the build. I hope I'm running the build. Yeah, running the build. I was running the build. You see now I've got a lot more warnings because we've got this Sonar Analyzer, the C# plugin warnings as well. And then there's going to be the end phase. The end phase does many things actually. If you didn't have MsBuild 14, so Rosslyn basically, Rosslyn supported MsBuild, then it runs a file-by-file analysis using Rosslyn internally because we package the Rosslyn DLLs inside. So if you are on MsBuild 12, still good. And it runs matrix calculation, so it computes the complexity, which is not done during the build. And finally, it runs many other analyzers like JavaScript analyzer if you've got a JavaScript analyzer installed on your server. So that's why I had a web project because that has JavaScript in it, and I already screwed out the JavaScript in it. So let's see it on the server what we have there. And basically, so as I said, it's running on localhost 9000. Here's my demo project. Oh, I've got one new bug. It's red. I failed the quality gate. I can't release. And then I can check out the issues. And let's say I want to see language-based issues. So I can select C# issues. And okay, there's an issue there. This class only have static methods, so why not have a static class? That's okay, like acceptable. There's commented out code, that's too bad. But we also have JavaScript issues, which is, we have a lot because jQuery, because Bootstrap, because whatever. We could exclude those files as well, so it's possible to exclude files. But for the time being, let's go to my app.js. I'm terrible at JavaScript, so I've got 2 issues in this small file. Oh, x equal x is usually not a good sign because you could just say true, or I'm not even sure if that's true or false in JavaScript. And at the same time, it says that, oh, don't use equal equal, you should use triple equal. So basically this is how you analyze your project. It is pushed to SonarQube and then you are happy. And sorry for being this long. If you have questions, please ask questions. I've got a couple more t-shirts. I've got small t-shirt as well, so if a lady wants to ask, you are the only one. Then I've got a t-shirt for you as well. And thank you for coming.
Thank you.
I'm gonna take a picture. I don't know if someone posted it already on Twitter or not. Like, so,
raise the hand?
yeah, raise the hands, but I'm stepping
1, 2,
back.
3, yay!
Yay! Exactly. Thank you. So questions?
Can we use TFS?
Can you use TFS? Very good question. Yes.
Yes.
And how much can you use TFS? So if you are, let's say, using Visual Studio Team Services, so online TFS basically. But TFS 2015, TFS 2013 is also supported. But let's say you've got Visual Studio Team Systems. You've got a build job set up. I do have a build job set up there. It is failing sometimes. I can edit this build job, and you'll see that we've got dedicated SonarQube pre and post step in Visual Studio Team Services, which is basically calling the command line tool, but it's like natively integrated at the build step, and I can hopefully, oh, there's no search here, that's too bad.
You can do all and control F.
Yeah, exactly. But basically you've got a pre-step, post-step, you can add it to your build pipeline. It will do the magic. What parameters does it need? It needs a project key, a project name, a version, and a SonarQube endpoint. Where's your SonarQube server? And you can set up the credentials for that in a secure way. So that comes with the team services. So yeah, that's how you do it online. Visual Studio 2015 has kind of a similar UI, but the XAML-based stuff is also supported. And also Jenkins we have a Jenkins plugin, but AppWeaver, Travis, wherever you do your CI, we support that because the pre-step, post-step is basically a command line tool. So if you actually go to, as I said, everything is open source, what I showed. So if you go to the GitHub repo, you can see how we set up, for example, the pull request analysis. It's in 6, we call CI server, our CI server is 6. If we are in a pull request, then run the begin step with a couple other parameters. Run a NuGet restore, run a build, and run the end phase. And this will do a pull request analysis for you. And the same applies for non-pull request analysis, but then you don't need this many parameters. So AppWeaver also supported, Travis also supported. Yeah?
You said we can use the SonarQube online server instead of installing a local server? Is
exactly.
there anything more that it's needed? Or
so right now, I think the main restriction is that we only support open source projects. That's a big restriction right now, but we didn't want to go all the way. Like, we had a trial period where you couldn't even subscribe, you had to send an email to us, we created an account for you, and then you could manage. Now you don't need to do that, you can register yourself, there's no interaction from us, but it needs to be an open source project. Yeah.
And in the case for VSTS, when integrated, the server, who's paying it? Because this is not necessarily open source, so you have to pay a license, or?
For SonarQube or for VSTS?
For SonarQube within VSTS, who's paying?
You set up your own server, so it can be on-prem.
So
yeah, it can be on-prem. You can set up a VM in Azure. But then, of course, standard rates apply. Like,
Yes. Thank you.
you can connect VSTS stuff with SonarCube.com, for example.
Okay. Only for free. Open source.
Yeah, open source. Yeah.
Can I analyze just subparts of a solution?
So what you can do is you can exclude projects. By default, we are not analyzing test projects, for example. But there's a pattern to match test projects. You can define your own if you want. There's a regex to exclude test projects. But also, you can exclude any kind of projects by simply defining a property in your CS project file, SonarCube exclude, and set it to true. So yes, you can. Yeah?
Will TypeScript be supported?
TypeScript, very, very good question. We have no plans for that. But there's always a but. I played with it a couple of weeks ago, last week, yeah, and it is feasible, so it's on our radar. I can't promise next year, but it's gonna come next year. But I haven't promised anything. Yeah.
How does it stack up against ndepend?
Ndepend, I'm not sure.
Right. Well, the bits of ndepend are most like really simple stuff. Your method is too long, your class is too long.
Yeah. So, for example, we've got these kind of rules as well. Like your class is like more than 1,000 lines. Don't do that. Your line is more than 300 characters. 500. Even 500. Okay. I mean, you can specify it yourself. Yeah.
And another good bit of ndepend is that the dashboard shows your evolution over time against your rules.
Yeah. So here what we have is, let's go back to Dory. So we also track through time. Basically, here you can see the background of this this chart. That's kind of generated from the past of the projects for that given metric. But you can't really go back in time to check, okay, what was the state like last year at this given point. There's some governance plugin which allows you to generate reports, PDF reports, so that way you could store your results, your previous results. But it's not like, okay, let's see what was the state yesterday at 5 p.m.
Let's
F# is not on our radar. So as I haven't promised anything for TypeScript, I'm not even saying anything about F#. Yeah.
Last two questions.
Last two questions? Yeah.
You talked many times about FXCop. What have you done the comparison with StyleCop, which is called source analysis?
No, we haven't. So with StyleCop, previously we had many maintainability rules, like, okay, class name should conform to this rule, blah blah. And we are trying to move away from maintainability, so more in the direction of bugs, and then to security issues. So I think we are not competing against StyleCop. The good thing is that StyleCop is based on Rosslyn, and we do have a project to embed any Rosslyn-based analyzer into a SonarCube plugin. So that grabs all the metadata for each rules, it creates a rule definition in SonarCube, and then you can use it the same way as we use our analyzers. And our analyzer is also shipped as NuGet package if you want to add it directly to a given project and not to a Visual Studio instance. Last question, and then I'm answering only privately.
With all the problems you reported to Microsoft, did they start using SonarLint yet?
So that's a very good question. No, they haven't. But we work together. So what I showed today is not just our work. We worked together with Microsoft for more than a year. So they were the ones who who did the magic with the scanner for MsBuild, and it's actually pretty amazing. So how do you inject your stuff into MsBuild execution without modifying your MsBuild call? And it turns out that in MsBuild there's a folder on your user app data path in MsBuild called import before. If you put a target file there, MsBuild will pick it up automatically. So what the pre-step does, it downloads the settings, it generates a target file, copies it to this folder, and that affects the MsBuild execution. And then the post-step ideally removes this file, but it doesn't. So I just realized it yesterday, so I created a ticket for that as well. But it doesn't really matter that it doesn't clean it up, because we wrote this target file in a way that it doesn't affect other builds than the one which you started, where you did your analysis. So it was a work done together with Microsoft, and also SonarLint has a connected mode. So in SonarLint you can connect a SonarQube server, pull down the rule set which is being used, and then inside SonarLint you will see the exact same issues as you see on your SonarQube server. So this part was also done by Microsoft. And coming back to Rosslyn, so Rosslyn is like a huge project. It's a very good candidate for code analysis. So this is another internal instance of SonarQube which we use for quality checking, for testing purposes. You can see that we analyze the Linux kernel, but our what's the sixth biggest project is Rosslyn, which we analyze. But we couldn't yet convince Microsoft that they put the effort into maintaining this whole stuff. Like, I can set it up for them, but if they don't look at it, that's not good enough. And we'll see. I mean, I submitted a couple of issues to them already. I hope they see the value in it. But it's an effort. Like, you have to commit as a team that from now on we are using SonarQube. Each team member is responsible for fixing their own issues.
Okay, thanks.
Thank you. And whoever received the t-shirt should come up front and receive the t-shirt as it is.